Mario, once again, I've been testing the efficiency of these bumpers. I made this bumper with this material, as I mentioned in another video. This is done with recycled plastic from a pop bottle. It worked out pretty good, but it's just something that I don't do often. I don't recycle plastic bottles. First of all, because I don't drink pop. And second of all, because it's just a lot of work. I have a little machine that does that, and it does it just fine. But it's just a lot easier to to save time and effort to buy the filament ready-made PETG. So I did make this bigger. That was my point with this video, a little bit larger in diameter, so that it would have a little more torque action on the trigger, which is the bottom piece right here, but everything's done at the same diameter, all throughout the plate, the triggers, the head, and this the bumper head, and this cover here. So I have been testing the efficiency of this, and this piece of paper that I put here is just a tag, a double sticky a sticky tag, double wrapped on itself, so that it creates a little bit of an extension, a further extension here, because my separation between these two is a little bit too wide for these two to trigger as the ball is coming this way. Unless, of course, I add some more of these bumpers, which was my intent to add it on this side of the table here. This is my pinball table. You can see I've been adding a few things here. My lights are just attached to a sequencing circuit. These two lights, this light is actually supposed to go on as well as this, but I just had them directly pinned to the board. There's no connector there, so I have to make a connector for a more permanent installation. But just testing the efficiency of this. I mean, that section right there works extremely well. You can score a lot of points just if the ball happens to drop in that direction there, either way, to the left or to the right. Okay, so it's getting stuck here because I have been moving things around, making holes, and this is my prototype actually. So I made these covers here, but the cover is a little bit slightly over the surface, so it sometimes if the ball doesn't have enough momentum, it prevents it from going through. So, but that side is working extremely well. I really like the way that's bumping, or creating that effect there, the bumping effect. So that's working well. This one right here, as I said, I added this piece of paper here, or tag, so that I can extend that and see if I can get a little more action between those two bumpers here. And it's kind of triggering, but not to my satisfaction here. So see, if I push here, it'll trigger it. So, but it needs to be closer in order for the action to be a little more intense there, more effective. Otherwise, the ball just goes right through that. It clicks once and that's it. So, okay, so when the ball comes out of here, when it's triggered, depending which side it goes, I'm quite happy with this layout here, so I'm going to leave that on the machine. I'm not going to change that because I've already changed this about 3 times. You can see all these holes here, extra holes that I drilled, so that I can relocate and orient these properly, so that it creates a little more immersive action between the bumpers. So the distance between these three is perfect. I'm not changing that. It's just enough for it to create that bounce back action with enough spacing there to let the ball through as it's going through each bumper. So the ball, you can see how that's working, but right here it's just a gap. It's a little too much. Anyway, so this video is about that. I just wanted to capture this, and just for record keeping, as I'm doing this project here, I like to make videos, and it's probably everybody does, just to as a show and tell, and just to keep track of progress here. The other thing I have added is these entry points here to my track, and this is my track system that I explained in another video how I did this. I'm just using nylon tubing. This is 1/8 tubing, nylon tubing, and this works just fine. You know, as the ball is able to travel through here. You know, the separation is just enough to hold the ball there in place. Boom, and then there's another entry point here. The angles to the entry gates is calculated by just a lot of trial and error. To I mean, there's probably some math that can be done here if you want to get really technical about these things. But for me, I just like working in real time and by trial and error and see what works and what doesn't. That way, you know, I don't spend too much time on paper, and you're actually doing this, getting the thing built and tested in real time. So that works just fine. I'm holding my camera with my hand, so I can't videotape a full game here, so that you can see how this works here. And those are about the right angle. So you see, I have markings here that I've been marking the position of these entry gates here. This gate also is going to have lights, but I have to drill the 2 holes, actually 3 holes. One for the mounting screw right here. This is a flush mount screw. There's no, it doesn't stick up. So these parts are designed for that recessed screw hole. And on the table, there's that hole, obviously, for that. It's got to be attached to the screw. And it's got to support the screw rather. And 2 other additional holes for these lights. There are 2 lights that come out from the bottom here. And there's a 3rd light. You don't see the wires here because they're embedded on the sides of this gate here, or this frame. But there's a light, a 3rd light here. So there are 3 LEDs there. These are supposed to be blinking LEDs with a sensor here. I'm supposed to have a sensor. So I think I'm going to modify this part to have a sensor so that when it senses the ball coming in, you know, it'll sense. It's just going to be a proximity sensor. When it senses that ball coming in, it'll turn on the lights or flick the lights on and off. And as the ball ends the travel here, provided you're able to complete that, it's going to have another sensor here to score. You know, I think I have these set on my preliminary layout for the electronics for 100 points. These are going to be about 1 point each because you get a lot of action there. So there's no point in scoring these high. So these are going to be 1 point. I mean, as you can see, I probably score about 20 points right there. So these are going to be one point each every time one triggers. These entry points are going to be about 100 if you're able to complete that at the ends with the sensors at the ends here. There's going to be 2 switches right here, one coming in this way. So if the ball drops there, there's probably going to be about 10 points. 10 points there. Wait a minute. No, I can't do that. Because the ball is going to drop right here. So I think I'm going to extend this so the ball drops after the switch here. And that way I can, if the ball comes in here, it'll hit that first switch, and then that'll generate 10 points. And then this drops a little bit further. Once you get this sensor to sense that, it'll generate 100 points there. So anywhere on up to, I believe I have this set to about 1,000 points, my counter electronic design there, the circuit. These are just going to sequence here and probably blink. You know, once this is set up. I am, believe it or not, I did buy. I had some Arduinos that I used on one of my printers before. I didn't do the programming. I just downloaded the software, to run the machine, the 3D printer. But I do have a couple of those that I had. One is a little bad. The other one is okay. One, I think it's got some kind of a power issue, so I have to fix that one. But the other one, I started experimenting with that and just kind of going back to some of the preliminary, basics of Arduino setups and programming. So it began to refresh my memory and how I started to do that. Lighting lights is not easy. It's not really hard. Triggering things is really not that hard. It's just a lot of getting familiar with the language that Arduino uses, the IDE software. So I decided to, dive in there and just see if I can just use one of those to control this, because otherwise it's a lot of logic circuitry that needs to be embedded here with a lot of unnecessary components. And so just to minimize that, I thought I dive in there and just bite the bullet again and see if I can just use one of those controllers to control this, which is what most people I think that are really into these things are doing. This is a project, like I said, just for fun. I don't plan on selling this. I don't plan on doing much with this except just for self-enjoyment, family use, friends use. So it's not a full scale machine. This is a miniature. Well, it's not that miniature. I would say it's probably because the miniature ones are 9 by 18 or something like that, about half the size of this. They call miniature machines. So this is a kind of a mid-size machine, and it's plenty for. It's plenty for my taste and my space limitations here, because over the years I've acquired a lot of stuff that I built, mainly radio control stuff. For those that have been following my channel, I have a lot of planes that I designed and I built over the years, so that those have taken pretty much all the room that I have. And now that I'm building this, I keep adding to the projects. You really need a big space to do a lot of this stuff. So I just don't have any more space. And so I decided to, unless I get rid, of course, of some other stuff that I don't plan on getting rid of. So I decided to do this machine mid-size. I mean, I'm working in my office here where I have all my electronic setup, which I need to organize a little bit better. Also, because just the way I work on a project and then I move on to the other one. And it's hard for me to find the time to really keep everything tidy, because I'm always working on things. So none of my stuff is really like a museum tidy. Some people like keeping things like that, but they don't do much. They're not. They just have things to show. If you're a do-it-yourselfer, you're going to have things all over the place all the time. As you probably already know that. So this is my setup here. This one also is going to have lights, same lights as this right here. This almost looks like I was telling my wife, what does that look like to you? And I go, doesn't that look like a Frozen theme, like the movie? Not that I want to get those names, because I think those are trademark names and copyrighted. So I don't. But it did give that illusion, with this clear plastic and the blue lights. These are actually blue. So the blue that you're seeing here is more of an aqua blue. The blue that I'm seeing here, it's more in this tone right here. So it's a deep blue. It's a really nice blue with these LEDs that I've been using here. All these LEDs have their own resistors. I bought them in a pack of, I think they come in packs of, I don't know, 20 LEDs each, and I have all kinds of colors that I can use here. So it just makes it a lot easier. I don't have to solder the voltage dropping resistor, because these all can run up to 12 volts. I'm actually running these through a just a sequencer board that I just built with a 4017 counter and a 555 clock chip. So it's really easy, it's just sequencing 1, 2, 3, and up to 10 and recycling that. So my idea was to use a few of those to distribute the lighting aesthetics on the table. I have one here, which I already have, and then have another one here, kind of around this area here, just to kind of sequence in a circle, or have a different pattern, and then have a full set of lights all the way around, RGB lights that I can change the color with with the proper electronic circuit to run around the perimeter of the machine. So you have a lot of lights. There's also a bunch of little holes that I drilled here, to give me another sequencer here of lights. That can be another circuit. And so all these circuits that I mentioned can be tied into the Arduino programmer or a controller. So that's not hard. You're just sending basically a signal to that circuit that's already built with all these sequencers, and just trigger that circuit independently at different times, and then you have all this action going on. So at least that's my idea for now. I am going to put that on paper, just to have all that solidified and have a little more control over what once that's done, then I can either trigger a set of lights as groups. So those would be groups of lights, basically. But if I decide to keep them independently, I can trigger all these, via the Arduino, and have those coupled, to different functions or actions in the gameplay. So, and that's another beauty about using a controller, computer controller to control these things, because you can do a lot of if this happens, then trigger this and activate also this like sounds and bells and whistles and all that stuff. So you can go nuts with this stuff right here. Just the sky's the limit when it comes to being creative with this. But this so far what I have, and so it's just another video. Stay tuned for more.